Hello, Gators. I wanted today to go through those dilution problems that we went through in the first day of class this week. And so I think I'll just run through the slides here and kind of talk about what we talked about in class, just so that you can refer to this if you wanted to go back and hear information. So you started with, there was a warm-up. You have 12 moles of NaCl. How many liters of 2.5 molar solution can you make? Show the dA with quantity unit substance. And again, there are kind of two ways you can solve this. You can solve it either using dA or using the four-step process. And let me go to the whiteboard for this. And so in terms of the four-step process, we have molarity. Equals moles of solute per liter of solution. Okay, well, moles of solute, there's 12. So in terms of moles, we have 12 moles in NaCl. In terms of molarity, we have a molarity of 2.5 mole. And in terms of liters or volume, that's our question mark. Okay, so we're solving for liters here. And you can basically multiply both sides by liters and then divide both sides by molarity to isolate liters of solution. So if we go liters up here and liters here, that will cancel liters here. And then if we divide both sides by molarity, it cancels molarity there. So then we get liters equals basically moles of solute over molarity, which then equals, well, the moles of solute is 12 moles of NaCl over 2.5 moles per liter equals liters. Moles will cancel, and then 12 divided by 2.5. I think, what was it, 4.8? Oops. NaCl. Okay, that's one way you can solve it. You can also solve this using dA. Now, this is your have value here. That's what you have. This is your want. So start with what you have. You have 12 moles in NaCl times, well, we have 1 liter of solution is 2.5 moles in NaCl. Moles in NaCl cancels, and again, 12 divided by 2.5 equals 4.8 moles in NaCl. Okay, so that was the first problem. Now we can go back to screen one here. And today we introduced diluting stock solutions. And the gist of this is that when you dilute a solution, you're starting out with some solution that has some solute dissolved in it. And so there's liquid and there's solute dissolved in it. When you dilute it, you're basically adding more liquid in without adding more solute. Because of that, the moles do not change. Now, the moles of the solute equals molarity times liters, since molarity is moles divided by liters. So we can just move liters up here. Moles of solute is molarity times liters. And the moles of the solute in the stock solution equals the moles of the solute after dilution. So because of that, we can say M1V1 equals our total number of moles. The total number of moles doesn't change, and that equals M2V2. Or, getting rid of the middle term here, M1V1 equals M2V2. So if we know any three of these values, we can solve for the fourth. One problem could be this. How many milliliters of 2.00 molar stock solution of CaCl2 would you need to make 0.50 liters of 0.300 molar CaCl2? Well, we have M1V1 equals M2V2, and therefore V1, if we divide both sides by M1, V1 equals V2 times M2 over M1. Now, V2 is our second volume here, the 0.5. Okay, M2 is our diluted molarity, 0.300. And then lastly, M1 is our stock solution, 2.00 mole. So we can substitute those in, and we get a volume of 0.75 liters. 0.075 liters, there's 1,000 milliliters per liter. That equals 75 milliliters. So in order to make the stock solution, once you have measured out your 75 milliliters, you would then fill the remainder of your half liter, so 425 milliliters, with water. Okay, a second problem could be this. Concentrated lemon juice has 0.3 molar citric acid. If you wanted to make 750 milliliters of 0.032 molar citric acid, how much stock solution do you need? So again, we could go to the whiteboard here. And we know that M1V1 equals M2V2. Well, in this problem, our M1 equals 0.30 mole. Our V1 equals, well, that's what we're solving for. Our M2, the final molarity we want, is 0.032 molar. And our final volume, it said, was 750 milliliters. Well, we can rearrange this equation a little bit to isolate V1 by dividing both sides by M1. So we get V1 equals M2 V2 over M1. Okay, then we can substitute in. So M2 was 0.032 molar times V2, which, oops, this is V2 here, was 750 milliliters, all over 0.30 molar. Molar will cancel, and then I think when you do the math out, this ends up being a volume of 80 milliliters. Okay, so you have 80 milliliters of stock solution. Now there is one more problem. So let's go back to screen one. And the last problem we had was concentrated lemon juice has a 0.30 molar citric acid. In order to make 450 milliliters of 0.025 molar juice, how much water must you add? Now this problem is really similar to the last one, except then there's an added step of you need to calculate the water instead of the stock solution needed. So if we go back to our whiteboard, a lot of this actually stays the same. So we can keep the equation the same, it stays the same. Actually, our M1 stays the same, but we do have a few changes. In reality, V1 is also what we're going to initially solve for, but our M2 here is slightly different. It's 0.025 mole. And then our V2 is, oh shoot, nope, that's right. What, 450 milliliters. So we now have, again, 3 of the variables. We're solving for the 4th. So we can again insert into here. So we have M2 is 0.025 molar. V2 is 450 milliliters. Over M1 is 0.30 molar. The molars cancel. And this, I believe, ended up as 37.5 milliliters. Okay, well, that's the stock solution. So then the total water is going to equal 450 minus the stock solution of 37.5, which equals then 412.5 milliliters. With sig figs, that's about equal to 410 milliliters. And that would be how much you had it. So you would need to add 410 milliliters of water, or 412.5 technically, to 37.5 milliliters of stock solution, and that should give you 450 milliliters of a 0.3 molar solution. Okay, so with that, that just briefly goes through what we talked about in class.